So over the last couple of years, worded problems with simultaneous equations have become really popular. So let's start with a basic and build our way up. Now, when you read this question, you won't know it's a simultaneous equation. So let's try and work out where in the question they give that away. So first off, they talk about cans of Coke and packets of crisps. Then they ask for the cost of one of each. So they've given us two different things to find out, which could be our two variables we've been looking for before. They've then given us two statements, which could form two separate equations. So let's have a go at this, shall we? Let's try and form an equation from number one. So, 4 cans of Coke and 3 packets of crisps costs £5.40. So, 4 cans of Coke. So the cost of a can of Coke I'm going to call X. And 4 times the cost of a can of Coke plus 3 times the cost of a packet of crisps is £5.40. 4 times the cost of a can of Coke plus 3 times the cost of a packet of crisps equals £5.40. And I've converted that into pence to make it easier. Now equation 2 follows on quite nicely. 5 times the cost of a can of Coke plus 6 times the cost of a packet of crisps equals £8.10. And my aim is to find the cost of 1 can and 1 packet. So I've got to now make one of my variables match, and luckily here I have a good situation where I can take this one and double the first one. So double the 4x, double the 3y, double the number, and call it equation 3. Now these two match, so I can do a subtract. So the bigger number is in the 3, so it's 3 take away 2, which is 3x, 8 take away 5. That cancels out, that eliminates. And this take away this is 270. So x is 90. Now I'll do my substitute. And I'll even write check over here to prepare that. I'll substitute in 1 and I'll check afterwards in 2. So x equals 90 goes into 4x plus 3y equals 540. So that's 360. Take 360 off both sides. And then I can work out y is 60. Now I'm not sure if it's correct, so I'm going to do my check in 2. So 2 is this. 5 times x, which is 90, is 450. 6 times y, which is 60, is 360. Does it make 810? Yes, it does. Success so far. So, let's set up another pair and solve to find just the first variable. Because by now, hopefully, you're confident on the general process. It's just the forming the worded questions. 1,000 tickets are sold for a concert. Okay? An adult ticket costs this, and a child ticket costs this. And then we know how much was collected in total. Well, if I've got two variables here, what are they? Well, I want to know the adult tickets sold, so that must be X. So what's Y? Well, that's the child tickets sold. And that's the number of them. Not the cost, because we know the cost already. Okay then. So, how many tickets were sold altogether? Well, that's 1,000, it says at the top. So the number of adult tickets add the number of child tickets must make 1,000. How can I write that in algebra? Well, the number of adult tickets plus the number of child tickets must total 1,000. So I've used the top bit of information. Now, the cost of the tickets by itself doesn't actually help. But when I know the total collected, it does. So the total collected is 7,300. But I don't know how many adult tickets were bought. I know it was X. So how much money did I make in total from adult tickets? Well, it was X of them multiplied by how much each one costs, which is £8.50. Now, to work out the total sales, I need to add to that the number of child tickets that were sold times by the cost of each of those. So now I've formed a pair of equations I can solve. If I multiply equation 1, I can make X or Y match. Now I'll do this quickly. I'm going to multiply equation 1 by 4.5. And I get 4.5x plus 4.5y equals 4,500. When I do my subtract, 2 take away 3 because it's got the bigger numbers, I get 4x equals 2,800, so x is 700. I can then say, well, the number of child tickets then must be 300. Job done. Now, if that was too quick, don't worry. The key part was setting up the equations, and that's what I want you to focus on in this video. Let's move on. It takes 3 hours for a boat to travel up 27 miles upstream, and it takes 2 hours to do 30 miles downstream. Find the speeds of the current and the boat. Okay. When it's travelling upstream, is the boat going with or against the current? And when it's going downstream, what's it doing? So, upstream is against the current, and downstream is with the current. How many miles does it do in 1 hour upstream. In 1 hour, it does 9 miles. Downstream, in 1 hour, it does 15 miles. Okay, so because the stream upstream it's against, the speed of the boat, take away the speed of the current, is 9. When it's downstream with it, the speed of the boat, add the current, makes it 15. That's equation 1, and that's equation 2. So upstream against is subtract, and with is add. Now look at your equations. Those are opposites, so when I add the equations, they will cancel out. I get 2b equals 24. And from there you can probably see that the current is 3. So it's working out that upstream and downstream with and without the current. And then meaning with the current is plus and against it is minus. Okay, doing well so far. Final worded problem we'll look at. A woman is now 30 years older than her son. 15 years ago, she was twice his age. How old are they now? Remember to pause if you want to try it. So pause now. Okay, 2 sentences. Let's turn each into a statement. First one. A woman is now 30 years older than her son. So if I call her age W and his age S, if I do her age, subtract her son's age, I get 30. Now you might have wanted to say her age subtract 30 is her son's, and we'll put that down as well to see which is most helpful. How old are they now? We still don't know. But 15 years ago, she was twice his age. So, her age minus 15 was equal to twice his age minus 15. Her age 15 years ago is twice his age 15 years ago. Her age 15 years ago is twice his age 15 years ago. Okay, now we're going to have to tidy this up because we've got some messy equations here. So, first thing I'm going to do, okay, is take 2s off both sides so that this disappears and it comes over here. Because in my first equation, I've got the 2 variables on the same side. So it becomes this. Now, minus 15 is in the way, so I'm going to add 15 to both sides. So that's W minus 2s equals minus 15. Okay. two equations now. W minus S equals 30, but W minus 2S equals minus 15. Now, these already match. So I'm going to do a subtraction straight away. But I've got to be careful because there's negatives all over the place. This one has more than this one. You can see the positive. So it's 1 take away 2. So it's minus S subtract minus 2S. Then it's 30 subtract minus 15. Minus S subtract minus 2S. So that becomes minus S add 2S. And this becomes 30 add 15. This becomes S, and this becomes 45. And her mum is 30 years older than the son, so she is now 75. Now let's do a check. 15 years ago, she was twice his age. So take 15 off hers and you get 60. Take 15 off his and he was 30. So she was twice his age. You may want to go through some of these again because there's some tricky questions here with forming being difficult. The manipulation before you go on to solve and then the solving. It's about reading it slowly and trying to work out how you can form your pair of equations. But practice will really help. Good luck.